Already, a new generation of robots are waiting in the wings. Machines that can repair themselves, teach themselves, even breed and evolve. One day we may end up sharing the planet with machines that are not only stronger than us, but more intelligent.
My last hurrah is going to be the building of a mobile, sensate, two-armed, articulate robot, something I think we can do by the year 2000. He's planning its route. It's looking into the map and saying, how do I do this whole route that you want me to do, which goes to the library and so forth, and away it goes. Behind every act of that robot, there's human thought that prevailed. But one day we expect robots to be controlled by a central computer. It'll tell each robot what it must do for the day. It'll monitor its work during the day. It'll shut them down at the end of the shift, start them up for the next shift. It'll measure the work throughout the day.
All work will be done by living machines. The robots will clothe and feed us. Rossum's Universal Robots.
So far, robots have remained glued to the factory floor. All brawn and no brain. So how close are scientists to building the robot of science fiction? The robots that can walk, talk, and hold things. Could they achieve in decades what's taken human evolution millions of years?
The robot's going to cook, clean, fetch and carry, offer an arm, handle security.
Thank you.
You're welcome.
And actually handle modest conversation.
I am about to move. Please stand clear.
In the future, robots will become our farmers, soldiers, builders, surgeons. They will clean our homes, clean our environment, and become our partners and agents in life. My own robots, like this one from the 3 Mile Island cleanup, have fixed up after accidents, work in construction. While we're sitting here, I have trucks with no operators in them driving in commercial mines to haul materials. But I think we'll go far beyond that.
I'm RB34.
Right, I'll take it from here. Come on, Mr. Rush. You ought to come with me.
Very good, sir.
Oh, come on.
I couldn't do that, sir. Are you refusing an order?
Robots throughout the world, we command you to murder mankind. To murder mankind. Spare no men, spare no women.
Don't touch me, you filthy robot!
To write the usual robot story in which the main purpose of the robot was to destroy his creator. Destroy his creator. Destroy his creator.
Asimov's 3 laws of robotics.
The first law is as follows. A robot may not harm a human being or through inaction allow a human being to come to harm.
The second law of robotics is that a robot must always obey a human being unless it's in conflict with the first law.
In other words, a robot can't be ordered to kill a human being.
And the third law of robotics is that a robot must never let itself come to harm.
After all, it's an expensive piece of equipment. Unless that violates rules 1 or 2.
Fire. You understand the mechanism?
Yes, Morpheus. A simple blaster.
All right. Now turn around here. Point it at the commander. Fire. You see, he's helpless, locked in a sub-electronic dilemma between my direct orders and his basic inhibitions against harming rational beings. Cancelled.
But the new breed of clever robots wouldn't exist but for one of the great unforeseen inventions of the 20th century. It all started exactly 50 years ago.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made of vacuum tubes like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows? Someday a machine like this may check up on your income tax.
ENIAC was a dim-witted giant that filled a large room, but had the computing power of a modern wristwatch. People saw a great future for this machine. The computer could only get bigger and bigger. In fact, the founder of IBM, Thomas Watson, made one of the biggest gaffes in scientific history when he predicted we'd only need 5 of them on the planet. Everyone thought big. There was one exception. In the same year as ENIAC, a work of fantasy hit the bookstands. In this far-fetched story, the logics, computers to you and me, are so small, there's one in every home. And that's not all.
You know the logic setup. You got a logic in your house. It looks like a vision receiver used to, and you punch the keys for what you want to get. The logics are all connected to the tank, a big building connected to all the other tanks in creation. And everything you want to see or hear, you punch for it and you get it. Very convenient.
Miniaturization, a computer in every home, and the Internet, and all predicted in 1946. What about today's predictions?
Within 50 years, there should be machines that are comparable in intelligence to the largest vertebrates, including human beings. After that, they'll be moving into new territory, and there will be super-intelligent machines able to do things that nothing on Earth can do today.
Hans Moravec, computer scientist and robot guru.
Current computers are approximately a factor of 1 million short of being able to match the processing power of the whole human nervous system. But computers are evolving at the rate of 1,000-fold every 15 years. And at that rate, we only have approximately 30 years to catch up that factor of 1 million, which means that by about 2030, there should be computers capable of holding programs that can do the whole job of a human nervous system.
Take a look at it. This car thinks fast enough to drive itself at the speed limit, take corners, slow down for other traffic, and find its way across the United States, all on its own. Robots like these are as clever as they come, but they're designed to do one specific task. Robots that could do many things would probably look a bit more familiar.
Very simple robots which have but a single function don't look anything at all like human beings. A vacuum cleaner which just sucks looks like a vacuum cleaner. However, if you want a robot to be as versatile as a man and yet live in our environment, then it would be nice to have him with the rough dimensions and shape and bending ability of a man, because then he would find all the objects in the environment built for human beings would also be built for him.
Limb by limb, scientists are finally piecing together the humanoid robot. Mechanical hands are already touch-sensitive, with fingers as dexterous as ours. They can even do some things human hands can't. This astonishing robot is modeled on the walk of a turkey, but at the MIT's Leg Lab, they believe it could one day be a person. No one has gotten closer to reproducing the confident, upright motion that we take for granted. Compared to the human model, it will be faster, stronger, and with almost limitless stamina. And if it all seems rather mechanical, meet the robot with a human face. She not only recognizes you, she can tell what mood you're in and smiles right back. The robot that puts you at your ease? Suddenly, we're very close to the original dream. After decades of inching forward, we're rapidly approaching the robot with the body of a super athlete. But strength is not enough. To be truly intelligent, it needs to think for itself. If science can achieve that, then our future really is fantastic. We are now entering one of the most exciting areas of science, where all the old rules are dissolving and anything seems possible. Robot evolution is taking off. The future could soon be out of our hands. 2001, the star of the show was HAL, a super-intelligent computer with a brain so complex it was almost human. So much so, it went mad. When Arthur C. Clarke wrote 2001, he thought that HAL would soon be a reality.
Probably before the end of this century, we will be able to construct computers or artificial intelligences which can go out on their own and develop lines of thought irrespective of any programming, and which may, in principle, be more intelligent than we are.
Today, he's slightly less optimistic, but can still see HAL on the horizon.
HAL certainly isn't realistic for the year 2001, but it's totally realistic for the year 2101, if not before.
One reason for HAL's late arrival is that, unlike human beings, machines find it very difficult to understand the world around them. The common sense rules that we take for granted aren't necessarily something we're born with. We learn a great deal about the world as we grow up. Scientists have tried to program all that information into a computer, but perhaps there's a simpler way. If you can design robots that learn like children, they'll grow up to achieve great things.
Hi there, Xavier. How are you? Nice to see you again today. In my children's lifetime, we could have a situation where robots are more intelligent than humans. This would mean it's a robot world, not a human world. Robots are in command.
Professor Kevin Warwick is Britain's leading prophet of the robot age. His tiny robots may only have the brain power of an insect, but everything they do, they've learnt to do for themselves. They were built without even knowing how to move, but their special electronic brains, called neural nets, quickly worked it out. They can even learn to refuel. So robots can learn for themselves, and soon they'll be teaching each other.
One robot can learn from another robot in very much the same sort of way that one human learns from another. The robot is looking around its environment, investigating the environment by trial and error, where another robot has already been there and done a certain thing. That robot can then tell the learning robot, this is what you do in that situation, or this is what you don't do. Same sort of thing as humans do.
All over the world, these remarkable micro-robots are coming on in leaps and bounds. What's exciting scientists now is that, like human beings, they're going to pass their intelligence on to their children. They call it robot evolution.
Robots can be taken in their present form and be evolved. Essentially, the best robots for any one generation, their characteristics can be taken, joined together and modified to form better robots for the next generation. You do that over a number of generations and you've got a much better robot.
This is how it works. The red robot is told to chase the yellow one, and the yellow one to get away. First generation, and neither of them know which way is up. 1,000 generations later, and we've got a genuine game of cat and mouse. And what happens if you send a 1,000-generation robot after one with only 200 generations under its belt? It's game over. This is the start of something very exciting, and it's not the science fiction writers talking now. These are the scientists at the cutting edge.
In a robot, evolution is going at blinding speed.
The robots themselves, or the computers, are contributing to the speed of their own evolution.
Success begets success, and the good ideas go into the next generation.
Then we will have more intelligent computers, intelligent machines, designing themselves more machines.
And as the machines become more intelligent, they will contribute more and more to their own evolution.
It gets out of our control very quickly.
Is anything beyond them? The human body is able to repair itself, even in the most delicate organ of all, the brain. Millions of neurons reroute messages to bypass damaged tissue. Surely machines will never be able to do that. Think again. If it's damaged, this computer from the Swiss Institute of Technology can repair itself unaided. It takes us another step closer to a virtually indestructible robot.
We can look at a scenario where a robot loses part of its body, but can simply clip another part of its body in. If they have a problem that can be corrected, they're almost immortal.
We'll be able to build robots that are as intelligent as humans and interact with us as humans do, and will become indistinguishable from humans. And I don't think this is going to happen in the very short term, but eventually down the line, I believe that that's what's going to happen.
Professor Rod Brooks, the self-styled bad boy of robotics. He wants to build the ultimate humanoid robot.
I just want to build the coolest robot around, and what could be better than a robot that is like a humanoid. That's been the dream of science fiction writers for a long time. Cog is a very complex robot. It has a head, which is with eyes on it. It's got actually two cameras in each eye, so that it can see a wide field of view and a very narrow field of view, such as we do. Right now it only has one arm, but it'll soon have a second arm. It's an arm that we can interact with, unlike a conventional robot arm. It's rather springy and compliant. It's got lots of sensors, and it needs those to be able to interact with people and do the sorts of things that humans can do in the world. And we're trying to have the system learn all those things as humans learn them, so that it has the sorts of performance that a human has.
And guess where he got his idea from?
When I was a teenager, the movie 2001 came out. In the movie, HAL was turned on on January 12th, 1992. And that date came by, and I realized we didn't have a HAL or anything like that on the horizons. In fact, I had a 0th birthday party for HAL at my house, and all my students came, and we had cake and champagne. And then I got to thinking, well, maybe I should try and make HAL, and that was really the inspiration for COG.
At the moment, COG incorporates all the best robots from around the world. As new advances emerge, COG will absorb them. The idea is he'll never stop growing. One day in the future, robots may see COG as their distant ancestor. But where will it end? In the Terminator films, our future is dominated by killer robots. Not much sign of Asimov's 3 laws here. Surviving humans wage a desperate war against the machines they have created. If the robots we create do become more powerful and more intelligent than us, the fundamental question is, will they act for good or evil?
A lot of people are afraid of the idea of robots taking over the world and moving around in the world and being something different. And I think this is part of the long history of humans having to give up their center of the universe.
Could it not be that a machine, having grown more intelligent than man, could also become more ethical, can also become gooder? Could he not take measures to ensure man's well-being, not because we command him to, but because he wants to?
Originally, we had to give up the notion that the Earth was the center of the universe. More recently, with Darwin, we had to give up the idea that we were fundamentally different from animals. Now, as we're starting to look at intelligent robots, we have to give up the idea that maybe we're the supreme intelligence here on Earth, and we may end up happier.
Gooder.
Taking over the world.
The visionaries may be right after all. One day in the not-so-distant future, robots will take their place alongside us. Ultimately, they may see us as weaker and less intelligent. When that happens, we can only hope they look kindly on their creators, and that we find a way to live together and share our fantastic future.
Next on UKTV Documentary, Bruce Parry takes part in the sacrificial ceremonies of a band of warriors in Tribe. And coming up in an hour, dinosaurs roam Oxford as a natural history goes back 3 billion years.